Okay, so the recording started. Greetings, everyone. You have joined the event being hosted by the Santa Clara Valley chapter of the IEEE Computational Intelligence Society and co-hosted by a number of other chapters in the country. My name is Vishnu Pendyala and I am the chapter chair. So we hold a unique position due to our strategic location and the wealth of expertise available to us. And today we have a distinguished speaker talk to us on Agentic AI. It's the title is Agentic AI Shaping the Future of Autonomy, Innovation, and Society. Agentic AI represents a groundbreaking shift in artificial intelligence, enabling systems to act autonomously. It helps make decisions. It makes decisions, achieves goals with minimal human intervention. So this talk explores the concept of agentic AI, its various types, adoption trends, and the transformative impact it is poised to have on industries and societies. From reshaping workflows to influencing ethical frameworks, the speaker is going to examine how this emerging technology is driving innovation and redefining humanity's relationship with intelligent systems. Dr. Narayan Srinivasa, the speaker for today, received his Ph.D. from the University of Florida in Gainesville in 1994 and was a Beckman Postdoctoral Fellow in the Human-Computer Intelligent Interaction Group at the Beckman Institute, University of Illinois at Urbana-Champaign from 1994 to 1997. Between 1998 and 2015, he was with HRL Labs in Malibu in California, where he became principal scientist and the director for Neural and Emergent Systems. At HRL, he worked on a wide range of AI projects for Boeing, General Motors, and the US government, including visual perception and computer vision, signal processing and sensor fusion, brain-inspired computing, and robotics. He joined Intel Labs in 2016 as chief scientist to lead the development of neuromorphic technology and played a key role in the development of Loihi neuromorphic chip. He is currently senior principal AI engineer and director for machine intelligence research programs at Intel Labs. He is responsible for accelerating Intel Labs uh, research on problems with high risk, but also with a potential for high reward to Intel. He has 126 issued US patents and over 100 articles in journals, magazines, and conferences. He is a fellow of the IEEE. So if you have any questions, please feel free to post them on the chat and I will try to relay them to the speaker when possible. So without much ado, please take it away, Dr. Narayan.
Thank you so much, Vishnu. Good evening, all. It's an honor to be here and give this presentation to all of you. So let me start my presentation by asking you a simple question. So how many decisions did you delegate today? If I asked you that question, let's say maybe you're at home and dealing with Alexa, or you're driving a car and you had a navigation system on, and so on. So you probably, if not today, at some point in time, recently interacted with a system that is, basically playing the role of AI, um, where the AI is serving as a tool, and you're interacting with it in order for you to sort of get responses to your queries. Or so let's say you post prompts or queries, and there's a system response. So it's sort of an interaction where you ask the queries and the system responds, and so on. And basically, that's the mode of interaction that we are all comfortable with today. But imagine that you had an AI system now that can actually, anticipate, plan, act on things that you wanted to do without requiring your prompts, without requiring your interaction with it. So enter this era of agentic AI that we are going to talk about today. That's going to shape, I believe, the future of autonomy, innovation, and society. So in this talk, what I'm planning to do is the following. So let me first start by giving you an introduction of the roots of where agentic AI came from. And then we'll look at some design, let's say blueprints or signatures of agentic AI that you will see today or in the future, and the types of agentic AI systems. And then we'll look at some considerations for how and when to use agentic AI and when not to use it. Then I'll look at some adoption trends in the marketplace today and give you several examples of innovation that's going on in the industry that's actually adopting this idea of agentic AI. Then we'll look at the societal impact of what exactly are we going to deal with in the future and how it's going to impact potentially all of us. And then I'll conclude with some summaries and some thoughts. So with that agenda, let's start. So basically, I'm going to start with AI success stories. And as we all know, AI has deep underpinnings from various past seminal work that has driven the technology to where it is today. But what I'm going to talk about here is tangible, measurable things that actually made an impact to us in terms of AI's contribution. The first thing we can think of, that made a big impact was this Deep Blue beating Kasparov, the chess champion, in 1997. And following which, about a decade later, Watson wins Jeopardy. So these are milestone events that made people think about AI as something that's going to, do great things. It's potentially going to change the world. It's going to automate stuff and so on. And then things started to take a much faster turn. So there was a Netflix prize event that many of you may know. There's a $1 million prize that was given for the winner of the system that made the best recommendations in 2009. Following that, in 2012, there's an ImageNet Vision Computer Challenge problem that basically produced an algorithm that was dramatically better in its accuracy than anything else before, any computer vision algorithms before that. And then in 2014, there's a self-driving demo that was done with the DARPA Grant Challenge that you may all recall, for both the urban and the rural challenges. I think this is the urban terrain and the rural challenges, the two challenges, 2014 and 15, I believe. And then the machine translation work that was done that was pretty impactful. And then you must have heard of the AlphaGo, where the computer was able to beat the world champion in 2016. And then came this big mega event of transformer models, which seems to, in 2017, which seems to have had a major impact in what we're going to talk about today. So there are two things I want to say here in this chart. So the blue bubbles here, basically are AI systems made of expert systems, kind of rules-based systems, and everything in yellow are database systems. And if you sort of think about it, the underpinnings of all these ideas, there's a whole slew of scientists and Turing Award winners and now Nobel Prize winners that enabled us to get to where we the transformer models and everything before that. Now, if you look at the transformer models, they're generative. So the transformer models basically enable the generative models that we see today. And the very first instance of that was text-to-text transformation. So basically, you have a corpus of text and you predict the next word, you feed that back, and you keep doing that over and over again to produce new text. So generating text was the basic idea, where OpenAI pioneered this idea with ChatGPT, and that took off in ways that nobody predicted. So, for example, then came the idea of translating images or transforming images to text, text to images, text to audio, text to video, text to even code today, and then you have audio to text, and then video to text also. So and this goes on and on. So there's new models every other week, you hear about new ideas and new concepts that are coming out based on transformer models. The important thing here is it's multimodal in nature. So it's not just text to text, but it started to transform into text to all these other modalities that are extremely powerful, and it forms the key ingredient for why agentic AI is possible. Now, if you look at the explosion I'm talking about here, is look at all the models that are available today, some open source, some not. But for all these different transformations, text to text, text to image, etc., there's a whole bunch of tools available today. And these are mature models that run that you can use to sort of test your ideas and create your own apps, if you will. So so we've gone from just the basic, text to text to an explosion of tools that are available today in the multimodal domain. Now, multimodality by itself is very important because of 4 reasons. First is contextual comprehension. So what does that mean? Basically, because you have multiple modalities of data available to the system, it's able to comprehend the situation better. It's got more information for the same event, and so it's able to look at it a little more carefully and with more information in order to discern what to do next. It sort of provides you with a natural way of interacting with the system. So because it can deal with audio and video and text, and it gives us a natural way to sort of interact with it. The third is accuracy enhancement. So because you have a higher signal to noise ratio, if you will, meaning you have more information from multiple modalities, you're able to more precisely estimate the context in which you're operating. And then last but not least, the capability enhancement. Because of all these various modalities, you're able to think of, you're dealing with now a very versatile system that can produce a whole different mode of interaction and a whole different set of capabilities that was not available with the unimodal systems. And again, if you look at the various tools that you have this little graphic here with 5 different color codes. So gaming, drug discovery recommendation systems, music composition is one type of, I've sort of clubbed them or clustered them into one group. You have text-based summarizations, autocorrection, entity recognition, chatbots as text-based processing. You have code stuff where code generation, code optimization, code review, code completion is another set of tools. And then video summarization, video captioning, video retrieval, video indexing, it's another set, and so on. So basically, there's a whole set of different, tools that have arisen because of the ability to use multimodality from the underpinnings of transformer models. So this, I believe, is a key sort of event, or is key sort of development, let's say, that enables the rise of this agentic AI. So let's now sort of make it more concrete. So what is agentic AI? So generally, you can sort of define it simply as follows. Agentic AI generally referred to as systems that are capable of autonomous decisions and taking them in order to achieve specific goals with limited or no human intervention. So, so let's sort of parse this up into a few principles that agentic AIs follow. So the key ones are that you have autonomy. That is, you're able to deal with your decision making without constant feedback, or doesn't require constant feedback from the humans. Goal-oriented behavior, they sort of are targeted to sort of satisfy a goal. They behave to achieve a particular goal. They interact with their environment constantly. So in this case, to maybe with other agents or even with the environment in which it's sensing some information and so on, in order to discern what decisions to make. And then it's also the ability to be able to learn from both its mistakes and from new information that comes its way. So, so the single and multi-agent systems that are, that apply these principles in complex workflows have now become what is represented in this agentic AI systems that you'll find today. In the talk, I'll explain more about what these systems look like and examples of how they operate. So that's sort of the overview of what an agentic AI system is. And if I sort of give you sort of ground this into a very simple example, I concocted this trip planning example where, let's say you ask the question, what's the weather in Lisbon? And you can sort of use, natural language processing, machine learning, and you can use the search algorithms and fetch the data readily when you ask the question like that. Now, if you ask the question, should I bring an overcoat to Lisbon for this week? You can use generative AI. Now, in this case, it requires both data and context. So day and night temperatures that week, the weather patterns that week, maybe some fashion trends that week that you need to be aware of, and so on. But when agentic AI this is the question you can do with agentic AI. So can you put together a packing list for me for this week in Lisbon, right? So if this is more specific to me, I'm talking about a packing list. So I'm assuming that it knows a bunch of things. And the agentic AI in this case would do the following, for example. It would retrieve the weather forecast. It would check your calendar. It would examine travel history for your preferences. Maybe you'd like to just take carry-ons and not check in bags. Maybe it creates an initial packing list based on your preferences. It checks to see if it satisfies constraints, the weight and space in the carry-on. Make sure that the list is adjusted so it ensures that it's compliant with all your constraints, and even orders missing items to be delivered to home in time for the trip if something is missing and needs to be there. So point being that these agentic systems can make decisions automatically, contextually, and with adaptability. And so that's the key sort of concept in what we're going from basically an AI as a tool to now an AI that has agency, the ability to do things on its own. So what are so we shouldn't forget some of the key enablers that actually drove to the rise of agentic AI. And I believe there are two things that have happened that are extremely important to point out. And one is the big convergence, which probably you know about, is basically the algorithmic development that was all the models from the academia and then leading companies, compute and memory, led by Intel, NVIDIA, AMD, Micron, and others. So advances in the architecture and memory, as well as the data and tools that became available, for democratization of AI, was the key to sort of when all this happened together, that became a big explosion of capability, which then made AI possible, and then what we see today even more possible. But at the same time, there's also another thing that has started to take place, which is this agentic AI stack. So what is that? Basically, the foundation of it always is the semiconductors. You have the computing systems. You have the cloud infrastructure that is enabled by these foundational platforms like the semiconductors. And then you have the foundation models that now we're talking about, which is based on transformers that are now capable of processing all this multimodal data, and then agentic orchestration layers, which basically serves as the layer that intermediates or mediates between the foundation and the applications, foundation models and the applications. And there are the picture here you see are the top 31 agentic vendors, AI vendors today, apparently. But the point being that this whole rise of agentic AI has benefited from decades of innovation and investment in both technology and infrastructure. So that sort of, I wanted to start with the basics of what agentic AI is, where it came from, and then now let's start looking at answer the question, why is it exactly, why is it useful? What is the big deal about it, right? The first thing I would say is enhanced productivity and efficiency. So the idea that you can handle complex tasks simultaneously, rapidly, and correctly. So being able to do that, will obviously enhance productivity and efficiency for any system or any company that's applying it. Autonomous decision-making is the second one. It minimizes the need for human in the loop, and especially for making decisions in repetitive or data-intensive tasks, it becomes very useful. Real-time adaptability, and it leverages feedback loops to make sure that your outputs are produced continuously and correctly. And then this other stuff that, which are sort of new because of the multimodal nature of how things are developed, is improved customer experiences. The fact that you can talk to this thing, this agent, meaningfully over long durations in a personalized manner, is a very important development that has sort of driven the adoption, if you will, or the growth in this area. And then strategic human AI interaction is another one where you're sort of complementing the human efforts for taking on, data intensive tasks while allowing us to think about more strategic or high level thinking. And then last but not the least, the ability to scale across industries. So it's a very versatile system that scales within and across sectors. And I'll show you examples of where and how this came to be and how the adoption is actually starting to take off now. So this is sort of the summary of basically what an agentic AI system is. Now let's dive into a little more details about, what are the various aspects of the agentic AI? What are the signatures that define them, particularly that are being used today? And what are the types of agentic AI, the taxonomy of it? I'll go through that next. So first, let's talk about the design signatures. So let's talk about the first concept called reflection. So to do that, let's look at this example. Let's say you have a user and you have a coder agent. In this case, just put Llama in there as an example, and say you tell the coder agent, say, hey, please write a code for me for this task. Okay, and the coder develops or produces a function that does that particular task for a variable X, let's say. And the user looks at it and then says, okay, I'm going to give you feedback. First of all, this is the program you wrote. Please check for correctness, style, efficiency, and provide suggestions on how to improve it. And that's the feedback to the coder agent. Now the agent, so this is sort of like a reflection concept, because now you're reflecting back what the coder agent produced in the first place in the form of saying, here is the program for the task you wrote, the output you produced. And then add a few more requirements or constraints that you want the coder agent to obey when it starts producing its next round of outputs. So it may produce an output saying, hey, there's a bug in line 34. I fixed it, and here's the new code, etc. And this goes on until the user is satisfied with the output, basically. So this reflective nature of interaction with the agent is one design signature that you'll find in agentic AI today. Then the other idea is tool use. So there are several tools that are available today for code execution, for interpretation, for search engines, web browsers, image captioning, object detection. So all these tools are basically there for the agent to access and use contextually, depending on what the task is. And that ability to use the tools contextually, depending on what the task is, an extremely important feature of agentic AI today. Now, the third idea I want to present is the planning and or reasoning idea. So here, let's say, to make this more concrete, let's say we have this prompt that says, it's a pretty complex question. If you have the prompt, if you look at it carefully, please generate an image of a girl reading a book whose pose is the same as the boy in the input image. And then please describe the new image with your voice. So that's the task. And to sort of look at an example image, the post determination could be done by this open post model to produce the output here. And then that can be then used to do a post to image. So VIT model, let's say, to produce an image of a girl in the same pose with the book. And then you do an image to text saying a girl is sitting on a bed reading a book. And then you basically do a text to speech that does fast speech models to produce data, produce a voice output that says that, basically. So this idea of being able to sequentially break down the tasks that are required for you to execute what was asked for in the prompt is quite complex. And this could never be done about a decade ago when I used to work on some of these models. But thanks to the multimodal nature of where we are today, this is much more possible today. And then the fourth signature I want to talk about basically, you could sort of look at this as, a notion of multi-agent collaboration. So what does that mean? So basically, let's say with an example again here, you have a user and you have a set of agents that are going to collaborate to answer or deliver what the user wants. In this case, the user is going to interact with a supervisor that serves as the interface to the external world. And the supervisor in turn has specialists or agents that are very good at what they do in particular areas. So this multi-agentic system is going to interact with the user to deliver an answer for it. For example, the question from the user is, I'm planning to go on a 2-day weekend trip close to Seattle, and so I'd like to know what are the hotels and places to go in Seattle. So the next thing that happens is the supervisor takes that input from the prompt from the user and then sends 2 separate prompts to those 2 specialists. To the weather specialist, the supervisor goes, check the weather in Seattle and nearby cities this weekend. And to the hotel specialist, he goes, hey, check the hotel availability in Seattle and nearby cities this weekend. And then the response comes back from the weather specialist and the hotel specialist saying, hey, Seattle is raining this weekend. And here's the weather for the conditions near and nearby cities, near Seattle. And then the hotel list is provided by the hotel specialist. And then the supervisor takes all that and produces a response to the user saying, Seattle is raining this weekend, but Olympia National Park is clear and I found a hotel there. So this sort of gives you a sense for the interaction between the multi-agents, between the agents and between the agent and the user. So this is another notion of agentic AI that is starting to creep in. And so this idea of partitioning or breaking the task into subtasks, where each subtask is sort of dealt with a specialist or an agent that is more adept at dealing with that data, is a concept that's supposedly much more, at least the publications reveal that it's much more accurate, first of all, and much more efficient. Now, given all this, I wanted to then sort of break down what are the types of agentic AI. So what are the characteristics first that we'll use to classify agentic AI systems? So there are 4 things I want to talk about here. First is intelligence. So what kind of intelligence does it exhibit? Is it able to autonomously analyze, reason, and make decisions on its own, and based on context and objectives? What kind of behaviors that it exhibits? Does it achieve or have adaptive actions to achieve its goals? Does it use feedback and tracks environmental changes in order to do so? What is the scope of the tasks it can accomplish? Is it a simple workflow that it can deal with, or much more complex workflows? Can it deal with regulated or unregulated environments? And then what are the best use cases for that particular type of agent? So I'll go through a list of agents. These are basically, think of them as just the types of taxonomy based on these 4 criteria. The first is fixed automation agent. So what is this? I mean, basically, if you look at the sequence here, you have an input trigger, you have a predefined rule, you execute an action based upon the predefined rule and send the output out. So from the intelligence perspective, there's no learning, adaptation, or memory. It's a predictable and consistent behavior that follows these predefined rules. In terms of scope, it's got limited to repetitive, well-defined tasks, and basically it's a structured. Any task with structured data can be used here. For example, auto, sort of response to in your email. So you're saying you're out of town or something. You should define the duration for which you'll be out of town, and you deliver a message, and it does it for anybody who tries to reach you during the time you're not in the office. So you can think of these as a digital assembly line with each step completed in exact order without deviation. Now, the second type would be this large language models enhanced or enabled agentic AI, where LLMs are now going to take the input trigger or prompt and provide contextual analysis from the text or prompt you provided, apply a rule-based constraint on it, and then produce an action. So in this case, the LLMs basically can process ambiguous inputs and sort of use contextual reasoning to extract outputs that can be then constrained by decisions using predefined rules or thresholds. Here again, the scope is there is no memory, it's stateless. Every single trigger has to be treated independently. So the second prompt you provided to the system has nothing to do with the first prompt unless you do reflection. And then tasks that require, sort of you can take ambiguous inputs and produce close enough outputs, which is sufficient for the task at hand. You can sort of think of these as smart assistants that understand the context, but I'll follow policy before making decisions. The third type would be a React sort of an agent. So what is this? Basically, it has this loop where it takes the input prompt and then reasons about it by breaking the problem down into smaller actionable parts. It takes actions on a part and then uses that to reason further and so on and so forth until it arrives at a solution that can be used. So best use cases in this case, for example, language agents that produce multi-step queries or project planning and management tools are examples of React type of agents. So you can think of this as a problem solver who is capable of thinking before acting. So they'll do some breaking down of the task, analyze it before actually producing an output. Then the next idea is the React plus RAG type of agent. So what does this mean? So now you insert knowledge in the form of documents or any prior information that is particular to the kind of queries you're going to post to the system. And then you have this feedback loop that allows you to sort of reason about it again by breaking the task down into smaller parts. Allows you to then produce actions that are much more accurate, minimizes hallucinations, and enables a much better high-stakes decision making. LLM agents as medical assistants are examples of that. So you can think of this as a problem solver who thinks and acts, but then also does fact checking with reliable sources before it produces actions or outputs. The next one I want to talk about is what we call as think of it as a tool-enabled AI agent or a system that uses tools. So basically, now in the reasoning loop, now you have the ability to select among this a suite of tools and then pick the right one given the context from the input trigger to then do the reasoning again as usual, but break it down by selecting tools, act on it, and then do the loop until you have the desired outcome. So here, you're talking about multi-step workflows. You're dynamically switching between the tools based on the requirements of the task. And it leverages APIs, databases, software tools, etc. And so it's a multi-tool integrator, acting like a multi-tool integrator. So GitHub Copilot would be an example of that. And so now we are talking about versatile problem solvers who use multiple tools, APIs, databases, and software. Then we're talking next about self-reflecting agents. So we talked about reflection as one of the properties of this agentic AI. Now, if you insert that into this loop of reasoning, execution, and then have reflection before it produces action, then this feedback loop can basically incrementally produce better and better outcomes. So there's a continuous improvement going on. And these are very important for tasks that require accountability to make sure that you're producing outputs that are useful and not harmful. So some use cases, like the code generation tool I talked about earlier, or the quality assurance example is one where you're talking about bots that can sort of explain and improve with feedback or self-reflection to produce outcomes that are useful. So self-reflecting agents basically can analyze their own decisions, and they can also correct their mistakes over time. The next idea is memory-enhanced agentic AI. So what is this? So basically, again, in this loop of reasoning and execution, you insert this idea of memory recall and memory update. So you have memory, you basically have long-term memory. You have a query that comes in. You look at the memory to see if something familiar to what the query has happened before. It uses that to then reason, break it down, etc., and executes in the loop. And if something new happens, and if there's an output that is produced that is novel, then it updates its memory, which you can also think of learning. And so it uses this loop of memory recall, memory update in this feedback loop of reasoning and execution in order to make the experience more tailor-made for recommendations across multiple interactions. So this is more personal in nature. You can take your data into account. For the Lisbon example I gave you earlier would fall into this category where it knows about you, it knows about your preferences, it uses that information along with the query that is proposed in order to produce meaningful outcomes or outputs that are useful for the user. So it brings personalization to the forefront by maintaining context and preferences. And last but not the least is the self-learning agentic AI. So this is the idea where you have learning fully in the loop with perception, reasoning, and action. Learning is happening at all places. And basically, this reasoning loop continues, or this loop continues until your goal is achieved. And this is something that, think of as autonomous learning and adaptation are crucial for these kinds of things. The conditions are normally changing, and it's not, very predictable. And those kinds of environments where you have autonomous robot deployments, swarm AI, etc., would be agentic AI of this kind. So basically, this I would think is the holy grail, where agents improve themselves over time without human assistance. So these are basically, think of them as, don't think of them as silos, but you can think of them as agentic AI types of systems that can be combined in many which ways to create complex agentic solutions, agentic AI solutions for problems that may require the interaction between these agents. So this is basically to describe the different types and then how you could possibly combine them in various which ways to create your own system. Now let's look at some considerations for how to use agentic AI. So I just posed them as 5 questions that you should ask for when to use it, and 5 to ask for when you should not use it. Let's start with the 5 that to help you choose when to use it. So the first question is, what is the complexity of the task? Is it a complex decision-making process that requires constant looking at various pieces of information, collating them, combining them into something that has to be then used to make real-time decisions, etc.? Then you may want to consider agentic AI. How often does this occur? So is it very frequent, requiring a lot of resources to be allocated in order to deliver on the requirement of the task, this high-frequency task? You may want to consider agentic AI. What is the expected volume of queries to process? Is it a high-volume system where there's lots of queries from different types of queries, and you have to respond with speed and efficiency across all those queries? Then you may want to consider agentic AI. Does the task require adaptability? So if things are changing constantly, and if the system has to be able to adapt to those requirements, then maybe you can consider agentic AI. And then last but not least, can the tasks benefit from learning? If the learning can improve its response over time, then you may want to consider agentic AI. This is not a, like a 5-commandment list or something like that, but basically things that we should normally think about when we want to look at agentic AI. Similarly, on the other side of the coin, when to avoid these, or at least today, as of today, they're not capable enough till, so we probably tend to avoid them for these kinds of questions. What is the accuracy requirements of the task? If the system has to be extremely accurate, for example, in a medical diagnostic situation where the patient's life is at stake, you may want to sort of avoid or probably just have human in the loop, if you will, in order to make sure the patient is safe. Is human expertise or emotional intelligence needed? These agents, as I know of today, do not exhibit empathy. If the task requires deep expertise or empathy, then you probably want to look at other ideas with human in the loop. What are the privacy and security issues? Are there task-sensitive information that you want to rely on, that you're going to share with the agentic AI that may be a troublesome issue because of the other repercussions it may cause? Then maybe not agentic AI. What are the regulatory and compliance requirements? Does it require strict compliance, without which you'll be violating legal, laws and some laws and other constraints? Then maybe it's better to sort of at least have a human in the loop to avoid agentic or to sort of keep that to minimum interaction. And then what are the costs versus benefits? This is an obvious question. If this task is very simple and it's prohibitive to implement something like an agentic AI for a very simple task, then you may want to choose not to use it. And so these are some of the thought processes and sort of think of as to considerations, let's say, as to think of when to use it and when not to use it. At least this is as of today. Maybe down the line, there'll be agentic AI that exhibits empathy, and then this will change, of course. Now, in terms of tools for agentic AI, there are many tools coming up. These are the three main ones that I see out there that are being used as an orchestration layer for agentic AI. There's LangGraph, which is an open source framework that basically deals with graphs. So it can do fine-grained control of flow and state of the applications with these complex flows. It can deal with this very scalable system and open source framework. So you can sort of use that to develop, orchestrations where your agentic AI can be expressed in the form of graphs. AutoGen is a tool by Microsoft that allows for building conversational agents. So this is like workflows for conversations between agents with ChatGPT like interfaces. And people are using this for developing various apps that are conversational in nature. And then Crew AI, as the name may suggest, is the ability to sort of create multi-agent systems where each agent has a role to play, and there's a collaboration between the role-based AI agents in order to deliver a cohesive solution or a single solution for a given problem. So these are some of the tools that are currently being used. And then you can ask, what are the metrics to measure agentic AI? And there would be system-level metrics clearly that says, that's focused on technical performance, resource allocation, such as latency per tool, cost per task completion, etc. There could be task completion metrics, like measure overall effectiveness of the agent. Does the agent succeed more often than not? How many steps did it take per task? How many human requests were required to complete the task? Meaning the more it requires human requests, the less agentic it is. And quality control, evaluate output accuracy and adherence to requirements. How good was it to meet all the requirements? The tool interaction, how effective was it in using multiple tools, all the available tools? How good was its selection accuracy, tool success rate, etc. So these are some of the considerations you would have for measuring how well your agentic AI is doing in a given problem, for a given problem. Now, so I'll switch gears now to the idea of trends and innovation. So there's a lot of work going on in the field today in terms of this industry adoption. And I'll first talk about market trends in general, and then we'll talk about specific use cases or examples from various industry as to how they're applying agentic AI for their problems. So first is the market trend. So if you look at the trends today, where we are to where we will be by 2030, it's expected that the annual growth rate at about 62.3% roughly, about 350, close to $340 billion by 2030 is the market size. That's a projection, of which the enterprise application will dominate. It'll grow from about 8 billion today to about 230 billion, capturing about 70% of the market by 2030. And then the consumer applications are going to grow a little, not as accelerated as the enterprise solutions, but then they're going to start picking up speed as more of these apps become democratized, meaning the tools become open source, and the ability to combine these tools to make agents of your choice in making will become more amenable for accelerating commercial consumer applications. So about $100 billion is the projection by 2030 for consumer applications. In terms of industries, there's technology, software, financial services, healthcare. These are all going to be, and manufacturing are going to be dominant. In terms of adoption rates, they're exceeding 75%. And again, this is all by 2030. and the rest of the many other industries as listed here that are all going to leverage agentic AI and build apps that are going to make their productivity and the list of use cases, the utilities I mentioned earlier, which agentic AI, come to fruition for their own use cases. And if you sort of dive into the focus areas, particularly across these industries, you're looking at strategic decision support, autonomous process optimization, knowledge work augmentation, multi-system orchestration, etc., personal customer engagement. So there's a whole set of different areas that are now being focused on in order to implement them, and some much faster than others. And the expectation is that this adoption will sort of gradually grow, with some areas dominating earlier, like technology, finance, law, medicine, etc., and then go into other areas as time passes by, thereby accelerating the growth of the whole area in general. In terms of geography and the breakdown of adoption, North America will be the leaders, about $110 billion by annual investments expected. Europe and China follow close behind, and then Asia Pacific, followed by Latin America and Middle East as expected, based on the trends today. Now, in terms of examples, I want to give you several examples of how agentic AI has been used and the innovation that these companies are leveraging to sort of make make a impact for them financially and otherwise. So let's talk about the first one, finance. JP Morgan Chase recently has talked about a multimodal AI framework. That what they did is they wanted to analyze complex legal documents that took a lot of time. So they wanted to extract the key data points in as quickly as possible in order to reduce the manual review costs that they incurred. Based on the data that from PricewaterhouseCoopers, it seems like they saved about 360,000 hours of manual review annually. And this obviously also, because of the ability to read text precisely, significantly reduce compliance risks, because the manual review could take time and they may miss points. It enhanced accuracy in the document analysis and also improved employee productivity. Another example is the Mayo Clinic, the healthcare division, especially in the radiology division. They have an AI framework that processes image data along with the patient history and lab results to enable automation across the entire value chain in the radiology department. So it basically reduced the diagnostic times by 30%, reduced the overall cost by 15%, and basically improved diagnostic accuracy and enhanced patient outcomes. So these are very different kind of application areas, but the impact is still significant for both of them. The third one I'm talking about is transportation and logistics. DHL is the company here that has been using AI to predict and orchestrate shipping demands, optimize their routes, and also manage warehouse operations. Again, the impact, as you can see here, is they have seen significant improvements in their operational costs and delivery times, and it resulted in enhanced customer satisfaction and reduced carbon footprint. In terms of Netflix, the media entertainment industry, basically they have used agentic AI to recommend and orchestrate content by analyzing viewing habits, ratings, and even visual content features. So this is multimodal clearly in nature. They claim that the subscription growth has increased by 10% because of the feedback, the personalized user experiences, and has boosted their revenue and improved their content strategy. So the story goes on across several industries. I want to show you one example of each from different walks of life in different industries, so to give you the sense for how impactful this has been today. Manufacturing, Siemens AG is an example where they used the AI to predict failures, equipment failures in particular, and then scheduling maintenance proactively. And this, again, as you can see in the middle column, has had a significant impact on the maintenance costs and the production uptime, and helps maintain the equipment better and more reliably, and also improve worker safety. In terms of Amazon, they're using it to analyze browsing behaviors, which is not, we all know that, but then they're combining it with visual preferences and purchase history to make it a multimodal system that apparently has increased their sales dramatically and improved customer retention and loyalty rates, basically. And this goes on to education as well. So AI is now being used to tailor the education needs by adjusting the difficulty of how the content is provided based on the performance and how engaging the student is with the system. And that has boosted the enrollment by a significant amount, improved the content development, reduced the content development costs by a lot. And basically the student experiences are much better and it enhanced more engagement from the students. Telecommunications, AT&T is an example where they are using AI to orchestrate the network data, customer interactions, and then optimize and personalize the network operations based on the personal requirements of the user. This is, of course, again, has financial impact, and non-financially, it has enhanced the network reliability and improved customer satisfaction. So the story goes on and on across various segments of the industry today. Public sector, this is an interesting one with Singapore, where they actually orchestrate and manage traffic flow, energy consumption, public safety. Again, this is to improve their overall traffic situation in Singapore, and they've reduced administrative cost, and they've attracted a lot of investment in seeing how the system works. But then the goal is to improve public services and enhance the quality of life for the citizens. And the list goes on and on in energy, again, to be able to get historical data and geographical and geophysical data to sort of combine them to find areas where they can drill better. And that has reduced environmental impact, improved their bottom line, but also had improved safety measures. Coca-Cola is another one where they're talking about marketing content based on analyzing consumer trends and personalizing the advertisements for them. Here again, customer engagement has increased. It has boosted their return on investment. And Walmart is another one where they're trying to sort of optimize their stock levels and do the supply chain management in a way that allows them to reduce the waste and enhance the supply relationships. So these are basically I wanted to deliberately pick a whole swath of different industries to show you the impact of agentic AI being used all across these different industries, not all as mature as you may want it to be in terms of the ability of the AI model, AI agent itself, but nevertheless being used today to make an impact for them financially and otherwise. So it's starting to pick up adoption across a whole swath of industries. Now, from the societal impact point of view, there are the things that we have to also look at from the perspective of ethical issues. In adopting agentic AI, what are some of the hairy things that we'll have to deal with? Is clearly a problem that we have to look at. The first would be accountability and liability. So suppose I'm using this for a diagnostic purpose. If I misdiagnose a patient, who's responsible for it? Is it the AI system, agentic AI? So determining the responsibility becomes sort of unclear, and there has to be clarity in terms of how we do that. There's clearly a lot of evidence for bias and discrimination in these models that they leverage to sort of make their decisions. Face recognition tools, for example, have much higher error rates for people of color. This is a well-known fact. Various publications show that. Privacy and surveillance, the ability to sort of personalize your behaviors or preference could then have the two sides to that coin. It could erode your privacy. It's because you'll have to share. The more you share, the more they know about you, which means you're sort of sacrificing your privacy for the agentic option that you get from it. Ethical dilemmas, like for example, if you have an autonomous vehicle and you have to choose between a passenger and a pedestrian safety, you're in a situation where you have to pick one or the other. What do you do? What does the agentic AI do there is a question that needs to be looked at. Of course, the lack of transparency is a common problem that many of these models face, in fact, most of them face. So how do you know how to audit these decision-making processes in order to assign credit or blame if there's no transparency at all? And then the last but not the least is the loss of jobs. So many of these companies that I mentioned earlier have started adopting agentic AI. And so especially for repetitive data-intensive tasks today, but that slowly could be encroaching into more, things that we humans are capable and are doing today, like in terms of software engineering, law, in terms of finance, in other technology areas. It's expected that some of these tools will replace humans, at least at the lower level. And so there would be potentially loss of jobs. So clearly, these are ethical issues that we're going to have to look at going forward in terms of adoption of agentic AI in our society today. So keeping that in mind, there's a regulatory, sort of push in the government agencies today to try to see how to get this under control in a point to the form where they're accountable and you're able to sort of assign a value or sort of give some sort of a guidance for when to use it and when not to use it, under which conditions. So data security and privacy, what do you do? There's regulatory maturity going in terms of drafting laws that are picking up steam for all these different vectors: operational transparency, autonomous action limits, human oversight requirements. That is, some of these cannot be fully agentic, and they don't have the agency to do everything, but maybe there have to be some oversight on it, etc. So, and then in terms of the adoption timeline by countries, Europe is leading the way in terms of the maturity index, if you're 0 to 100, 100 being that it's fully mature and the rules are all in place and fully agreed upon by the parties involved in order for them to be deployed in a full scale without any issues, and fully about everybody being clear about what the rules are of engagement. China and US following suit there, and then there is also overall trend is growing, where regulatory impact is going to make hopefully the adoption more safe and more reliable and less impactful on society. Now, transforming the workplace is I believe where this is going to fundamentally change the way we do business if you deploy more of these agents. In fact, we're entering an era where this multi-agentic workforce is going to be deployed where the agents outnumber human employees. So recently, there's a quote from a multinational company CEO saying that in 2 years, we'll have 50,000 employees, but 100 million agents. So you can sort of see the scale here in terms of what it's going to do in various tasks and how the industries are planning to deploy them in order to accelerate and be more productive in their own functions. It's going to transform performance because it's going to have this ability to not just execute tasks, but execute them, with this idea of long thinking, to be able to solve very complex problems. And this is getting better with time, and the more the tools develop for long thinking, it's going to do many more complex problems that are currently only within the reach of humans. And then it's going to organize the whole industry, because what it's going to do is it's going to allow agents to autonomously spawn, train, deploy, monitor, and retire themselves based on organizational needs. And so without any human micromanagement. So it clearly, if we're talking about a completely different workplace now, where these agents are going to interact with humans and between themselves to make things much more efficient and productive. And then we can sort of think about all this from the perspective of a digital workforce or a digital labor force. So the traditional silos will blur because these agents are going to now be able to do end-to-end tasks, not just put them in a silo where they're going to do one particular thing, because multiple agents would be combined to enable an end-to-end task. So it will shift from basically rigid hierarchies to more fluid structures where agents can be combined in many which ways to accomplish various tasks. The focus of talent will also evolve because now the systems will now sort of rely on human ingenuity, but agentic efficiency. So they will sort of partition the tasks and the workloads based on the demarcation of how humans can create, whereas agents can be very efficient in executing what is asked of them for a given goal. And then the command to coordination idea, where the leaders are going to more basically focus on designing workflows that integrate all these agents in order to do adaptable, ethical decision making in order to satisfy the organizational goals. So basically, what we're talking about here is we're shifting the conversation now from what I began in my talk as we're using AI as a tool to now looking at AI as digital labor themselves, directly as digital labor because of agentic AI capabilities. So it's food for thought. It's something to sort of ruminate over, and it's coming. It's going to impact our society potentially in ways like I've talked about here, and it's going to sort of over time, affect maybe many of us. But in summary, I would say agentic AI is coming of age because of all these advancements, investments in AI technology. There are several types of agentic AI being developed at rapid pace here to potentially address a large number of markets, particularly, I feel, in technology, healthcare, law, and financial services by 2030. These systems will excel at tasks that are, at least at this point, mundane and repetitive, enabling humans to focus more on strategic thinking roles. But then there are these ethical issues that need to be addressed, including loss of jobs, lack of transparency, and other dilemmas that will affect our society going forward. So it's key to establish regulations to monitor the impact of this agentic AI in order to establish clear rules of adoption, and that actually may help accelerate its growth even more. And last but not least, we are seeing what I think is going to become one of the biggest economic revolutions in history, because we're talking about age of massively scalable digital labor. With that, I will conclude my presentation, and I'll be more than happy to discuss and take questions. Thank you.
Thanks, Narayan. That was really very insightful, concise, and comprehensive. Very, very well articulated.
Thank you so much.
So we do have some questions. So Chandru is asking, what is the anticipated cost curve for agents AI, agentic AI, maybe that's what he means. Anticipated cost curve, and when will the performance cost trade-off benefit rapid adoption?
Yeah, so cost curve data, I don't have particularly, it depends on the task, right? I mean, so typically, if you're talking about, looking up databases to extract information, things like that, that's going to be much more readily available and much cheaper than if you're talking about more complex tasks. So you could probably have a third dimension in terms of complexity of the tasks to create a curve. But in general, the trend would be that, each industry will have to make a call as to how much, investments they have currently in place in terms of resources to accomplish a particular task, and what would it benefit from if it did what it did with the agentic AI, and how reliable would that be, right? So precise answer to that would be difficult, but the threshold, and so to answer your question, there's a particular threshold will also be a difficult one because it depends on the complexity of the task. But in general, there is going to be a threshold depending on the task for which you can make a sort of a decision as to whether to use it or not. So for example, if there's a lot of regulations, right, and if your AI has to jump through a whole bunch of hoops and keep track of that in order to even deliver on a task for you, it may be too complex for you to use it. On the other hand, if it's mundane, repetitive, or if it's very easy to combine tools today to accomplish your task, maybe it is a desirable thing. And if you can do it at scale, then it makes your cost benefit analysis in favor of agentic AI. So it's hard to give a specific answer to that. There's no specific threshold. It depends on the complexity. But in general, the trends are you have to weigh the pros and cons in terms of what the agency of the AI system can do and to benefit at scale versus what you are doing today with what you have in place.
Yeah, thanks for that. So the question from Peter is what is the potential for optimization of the CPU usage and thus the power cost of responding or operating?
What is the
Uh,
CPU?
yeah, CPU usage. I think he's talking about the environmental impact and stuff like that.
Oh, I see. I see. Um, yeah. So there's in fact the Singapore government example that I gave you was one example where um, the goal was to minimize um, the traffic jams in the city by taking into account data from sensors and other databases to sort of put an agentic AI to manage the traffic, in the city, interact the traffic lights and so on, by collecting information across multiple sensors. So um, clearly there is some, in this particular case, the goal was to reduce the carbon footprint by, and minimize accidents and keep the citizens safe. Um, so that's an example where it actually, um, impacted the environment directly by reducing carbon footprint. But then there are many other examples, like for example, the oil drilling situation where we're talking from, I think it was British Petroleum that is working on it to sort of minimize the contamination in the oil drilling rigs by precisely locating, instead of blindly drilling around an area and creating pollution in the waterways, being much more precise and accurate in extracting the oil from a particular location, for example, using agentic AI seems to be working for them. So there is another one where you could sort of think of it as an impact, positive impact, right? So I mean, it's still think of it as a very early stage development, but the agency in AI is coming. And the more tools are available, especially in the multimodal flavor, it is inevitable that they can be combined to create a more agency in AI, which is basically the theme of the talk. So, agentic AI is something that is become more plausible today and potentially going to impact more industry as we speak and going forward.
Yeah, I think the question is more related to the CPU. I mean, he says CPU, but I think he meant GPU usage.
Oh, you mean the processors? Oh, sorry,
Yeah,
I
the
completely
processor.
understood.
Yeah.
Oh, okay. Oh, yeah. Oh, yeah, of course. Yeah. CPU, GPUs. There is clearly maybe things that you can do with agentic AI that would be impactful there. For example, if your goal was to you know reduce a thermal footprint, and maybe optimize for improving your sort of multi-objective function where you have contrasting objectives, sort of working against each other. These kinds of tools may help you figure out a solution for this complex optimization problem more efficiently, potentially. So the future of designing architectures that may be more efficient, at the same time more amenable for scaling by dealing with thermal constraints, etc., could be something that could be coming. So these agents will possibly be experts or a multimodal agent where you would have some agents very expert, sort of knowledgeable about rules, design rules, others about thermal footprints, and so on, that interact together to satisfy a common objective. But this is an idea that that I think also could be possible going into the future.
Yeah, the questions are just pouring in. One other question is, out of the 335 billion projected spend on agentic AI, how much of this is in the application level versus foundational model versus infrastructure versus semiconductors?
Yeah, so that's a good question. So what the data I collected was for just the agentic AI applications, the impact, so the investments in the agentic AI stack. So there's the agent, I talked about the agentic AI stack. So let me go back to that slide. Let me go there first. Yeah, so majority, more than 70% of the budget would be, or the dollars would be in the application layer. But then, the definitely, and the semiconductor area is another one that would definitely be required in terms of, producing more and more performance for the requirements of the agentic AI to function efficiently. Let me go back to that slide first. I think it was this one right here. Right. Yeah, so in the stack, there's a lot of investment going on in the application layer for enabling all the or using all the tools that are there today. And clearly, everything is changing in the stack, right? It's not all fixed. So the semiconductors, cloud infrastructure, the ability of the semiconductors to do more processing, which then impacts the ability of the cloud infrastructure to mine information faster and provide data for the foundation models, which then allows for the orchestration to be more efficient, which then benefits the applications that are sitting on top. So there is investments across the stack for sure in order to do better and better in terms of what it can do as an agency, from an agentic AI point of view. Breakdown-wise, looks like all the examples I gave you are more on the application side, and there are many more that I did not give you, that are also looking like more on the application side. So I would say between 50 to 60% at least on the application layer. And then the other investments, will automatically, either due to agentic AI or not, would drive the performance of the agentic AI stack towards better and better models, maybe. Yeah, but I think it's about 60% is applications, the number I gave you.
Okay, so the next question is, how do we invest in this revolution?
Yeah, so so the investment choice is basically, again, so the ability for you to so the key question is, what are you, so when you say invest, what do you want to accomplish from it? So if you want to, create a digital labor force that would make your company more efficient or more productive, then maybe it is in your interest to create applications that would drive that forward. If you're interested, if you're looking at enabling any part of the stack that would then make agentic AI better, where in which you also enter the company that's interested makes benefits from the overall success of the stack, then you want to invest there. So the investments, particularly across the stack, would depend on where you're coming from, I suppose. But in general, the stack is what keeps all this together. So it has to be across the stack. And I believe that all these elements will benefit from agentic AI going forward. So the investments across the stack will benefit the whole field going forward.
Yeah. So monetary investment is probably a big thing, but how can professionals develop skills to get into this agentic AI? Because I've seen NA10 and Zapier, these are all like drag and drop, right? I mean, I didn't see much skill required for building agentic AI. So do you see need for those kind of skills? I mean, some specialized skills for agentic AI?
Yeah, so that's a very good question, because the way it's set up right now, it's more of this kind that you talked about, the drag and drop, where you have agents that are good at what they do, and you sort of create a multi-agent system that, and then you try it out for satisfying some particular goal that you have in mind for the problem that you need to solve. And so, if you're an expert in the topic that you clearly can define or articulate the goals that you want to measure the system by, and and provide the right suite of tools for it to access contextually. So these are all sort of it's a meta skill. It's not like a skill at level of writing code for doing AI models, but more like combination of various tools that are available in order to accomplish a goal that would make your process more productive. Is the skill we're talking about in the stack here for applications. But clearly, there'll be new foundation models, there'll be new orchestration capability, better cloud infrastructure, and potentially much better semiconductors too to drive all this. But yeah, in terms of actually a skill, if you want to ask, how to create an agency for an AI system that solves your problem, I think it still requires some thinking from a human expertise point of view to see what are the various things available out there that I can leverage to provide the agentic AI options for interaction and reasoning to produce what I need to accomplish.
Yeah.
It's more drag and drop and combination of the drag and drop that builds upon all this infrastructure and investments that's already been there. And there's more of these apps coming out, I don't know, on a weekly basis, maybe on a daily basis. And so there's more choices to have and to use and to leverage, basically.
So it looks like it's a low entry, right? It doesn't require really highly specialized skills to get into.
Well, it depends on, so you need to understand you need to be able to strategically think about the components that you need. So at that level, you need to be able to think about the problem you want to solve, right? And then provided the right set of tools, and that selection of the tools is another choice that you have to make depending on your problem and what you have to do. But in general, you don't have to go down to the level of the nuts and bolts of coding, for example. It's more about, which is why I think it's going to be more powerful, because it's more about using the tools, just like we're using foundation models today, where we're sending a prompt in and writing code through this notion of vibe coding, for example. Is very powerful, where you can actually write code without even knowing much about Python or PyTorch or whatever, which is sort of along the lines of where we'll end up being, because it's abstracted up to a higher level, where you're sort of going to use those abstracted tools to then compile them or combine them in ways that would meet your goal. So designing that system for your organizational workflow to accomplish a goal would be more the skill that you'll need.
Okay. And so Tarun is asking about the scope and application capabilities in precision manufacturing, because it is a high cost and high stakes industry.
Yeah, so precision manufacturing. So correct me if I'm wrong, Tarun. So are you talking about like aircraft parts where you have to make them extremely precise, the engine blades or something that has to be extremely precise in order for it to function correctly? Is that what you mean by precision engineering? What could you please clarify?
So he says semiconductor manufacturing, bioscience.
Okay. Yeah. So, I mean, so there again, how to leverage the tools. Right? So precision engineering, it depends on how you're going to organize your stack again. How are you going to, what are you going to do from the perspective of, leveraging the tools here? So I don't know if there's anything particular here that addresses that directly that I've seen, but that doesn't mean that doesn't exist. Because clearly this is such a vast and developing field that it's impossible for any one person to know about all the different tools there. But I suspect there will be something. So precision engineering could be something where you're talking about your goals being to meet certain metrics under certain time constraints, maybe, and to formulate that goal, and then to be able to find tools that would serve that purpose of agentic AI by combining them and providing contextual data from your system that the system can then, agentic AI can then use to reason about it. So the key is to sort of have a goal and then have a set of the components, the right mix of components assembled in a way that allows you to reason from data that you provided, right? So that's the key, to be able to structure it that way in order for you to benefit from something like this, to provide it agency in order to be, in order for it to guide itself to accomplish a goal, no matter which problem you're talking about. So that's how you want to think about it. And then for a particular case, it depends on what's there and what needs to be developed in order to accomplish.
Okay, Tarun is happy with the answer. So the next question is from Jill. She is asking, as a creative in a classified environment, how do I develop in a silo? Apparently, she is working in some kind of restricted environment, which cannot be public.
So yeah, so one advice I would say is, you may want to leverage tools that are open source, right? But then put it in your environment and use it for developing your custom and restricted use cases. Because if you want to develop something where others can't give you feedback because of the nature of the data you're dealing with or the restricted environment you have access to, then I don't. So it becomes a little more difficult for a general purpose. Somebody who's an expert to sort of get in there, right? So I would advise taking the available tools that are open source, particularly, so you can sort of get to know more about the tools from the perspective of even the code level, to sort of get more insights into how the system or the tools operate in order to then put together something that is restrictive, because you can't sort of interact openly with others. So I think, yeah, so that's the way to go there, maybe.
Yeah. And then I think you kind of answered this question, but the question is how much power energy is required to support all this digital labor?
Yeah.
I
So
think,
that has always been that is a problem today, but it's people are talking about nuclear plants to support the cloud infrastructure to then support foundation models on top of it. But yeah, so but then there's some encouraging new developments like DeepSeek and others where they're trying to sort of figure out ways to deploy these models that are more efficient, right? So this fight between efficiency and productivity and functionality is always going to be there. In any new technology, that will be there, and we'll hit a sweet spot at some point, maybe where there's a good mix of good balance, let's say, between the various let's say conflicting objectives here. But yeah, so it is, there are people are talking about bigger and bigger models, and we all know that, billions and trillions of parameters now, and so on. But the question is, what is the return on the investment for the scale? That's still unclear, as we go forward. And then the question is, do we also need that level of scale in order to accomplish agentic AI tasks, which is the other question we need to sort of look at. Maybe not all tasks require that complexity or that power-hungry, infrastructure or solutions. So leveraging what is there and then building your own custom apps to circumvent or leverage the benefit of all the tools that are available out there to then create a custom AI solution, agentic AI solution may still be extremely efficient from your perspective, for your own problem, even though the enablement of that tool might have taken a bunch of energy to create in the first place, like the foundation model.
okay, Gustavo says, amazing presentation, thanks. And then he also has a question, probably more questions, but here's the one I can see right now. Can you recommend environmental impacts information specific to agentic AI. We at IEEE are trying to standardize such environmental impacts and would appreciate your vision.
So, so the environmental impact, the first thing, so one of the things we want to do is, it would be nice if this could be done is to, one of the thoughts I had is to have papers, anything that is published out there or literature, for example, to sort of say how much energy or how much did it take for them to build the model in the first place in terms of energy perspective? How much cost did they incur? How much kilowatt hours they burnt in order to produce a model? And incentivize models that are more efficient, meaning that you would have some sort of awards on a yearly basis for the best model with not just accuracy and performance, but also energy, some sort of a combined metric maybe. So sort of figure out ways to incentivize making the models more lean and efficient right from the foundation where things are created all the way up the stack, so that we have a little more handle on, or let's say a little more visibility into what are the culprits or who are the culprits that create inefficient solutions, and how can we sort of circumvent them or pick the options that may be available because of the incentivizing idea to then navigate that problem. So right now it's all like, more power, more parameters and more everything in order to create the best and most complex models capable of a lot of things, which is great. But then from the agentic AI point of view, again, I said, you don't need, you can leverage what was already done in order to create your own particular solution, right? But in general, in order for this to be scalable and more friendly or more, let's say, impactful to society, we probably need to pay attention to that aspect of it, which is not very, not in the forefront today, but maybe it needs to start becoming that. So, for example, the regulatory impact could be that, we put in rules that allow or force, not force, but maybe require some form of, let's say, information that it needs to be shared with the public as to, what is the environmental impact from the perspective of consumption of energy, maybe, and then that would then make an impact on, it will also allow inform public about what it takes to build these and how to sort of navigate that let's say landscape to come up with a solution that makes the most sense from an environmental perspective. It's a very complex problem. It requires a joint. It requires the willingness, the will across the stack to play the game in the right way in order for it to become reality. Right now, there is no such regulation or there's no such requirement. It's more about performance, more about how capable they are, which it seems the law of scaling seems to suggest that the bigger the models, the better from that perspective. But yeah, so it's a joint effort across the stack, the community here that you see in this picture, that would, sort of play a role in shaping that in the future.
Yeah, Gustavo also would like to know how agentic AI can be used for project management. So he says, can you recommend PMI, Infinity, or other agentic AI application for project managers?
Yeah, so there was, I had a slide on that. I don't know, maybe let me just see if I can get to that quickly. This one right here. So, there are tools out there now that can allow you to sort of look at program management tools, so sort of project planning and program management tools, wherein you can sort of take the workflow and break it into smaller actionable parts and create agents for those actionable parts, and then combine them, to create a solution for your problem. So in this picture that you see, there's a whole different aspects of, the project management here, right? You have the task automation, scheduling, you have things like time tracking, budget management, etc. So it may be possible if you can sort of figure out tools that would allow you to take information, maybe multimodal, to to enable automatic reasoning, decision making across this different elements of the project management solution, then maybe there is a way to then create an agentic AI for it. So I think there are tools out there already today, if I'm not mistaken, Trello and others that are out there that allow you to leverage AI, agentic AI for project management. But yeah, please take a look at that. I mean, this literature, I mean, like I said, the landscape is so vast and changing. But I believe there are at least 4 or 5 tools. I don't recall all the names, but there are 4 or 5 tools that are out there that are specifically for project management based on agentic AI.
So Arup Chakraborty is asking, how would you define human ingenuity as opposed to agentic AI efficiency driving by learning capabilities?
Yeah. So, well, so this is a little bit of a tricky thing because if you think about what large language models can do today, it's still so you can sort of think of the way in which it produces answers. You may think it's actually very creative because you didn't anticipate the answer. But then if you look at the volume of data that it has to produce that answer, it is pretty much the entire internet or the web, right? So it's more like an interpolation problem rather than an extrapolation problem. So going beyond what it knows. And so this idea of there are many ideas that are coming out now that are going to look into that question as to how can you engineer these systems to think beyond what they actually have from the data perspective, right? And that is not, I don't think it's there today. I mean, but then there's metrics that are people are sort of creating to even evaluate if it's possible, the generalizability of the system to do things that it was not programmed to do, right? So humans, I mean, we're comparing apples and oranges here. I mean, I wouldn't call agentic AIs anywhere close to humans from that perspective. But then it's interesting to ask the question as to how creative are these agents, and can we put a measure on it to understand what it can do in the future if you were to design something that would overcome some of the obstacles. That's an interesting question that I think people are working on. But at the creative side of it, I don't think these are, although it looks like human level problem solving, is more like sort of breaking the stuff up into logical steps and then sort of looking at it from an execution point of view in a sequence that makes sense, right, logically. But I don't think it's as creative as we are today. That's my opinion, of course. People may argue about it.
Yeah, I agree. And then a question from Wendell. Um, you mentioned some forecast for agentic AI by 2030 for enterprise and consumer segments. How much of the AI inference workload will be non-agentic in 2030?
Yeah, so that's a great question too. I mean, so yeah, so this is so this is more about think of it this way, right? So this is a new market. This is sort of think of it as it will cannibalize some of the existing things that we do in terms of its use cases, and then there'll be completely new things that we do that we never were able to do before because of the agency provided to AI, right? So I believe that there'll be a mix of the two. I mean, so in terms of this is purely about projection of what happens to the enterprise industry if they used agentic AI, right? It's not the whole market for AI, but it's particularly about agentic AI. So meaning that you want to have systems autonomously, anticipate, plan, and act without human intervention or human management, right? So this projection is more along for that. And of course, I got my data from Gartner, Accenture, McKinsey, and Forrester.com. Did some research to find out what the trends are, and this graph is based on that analysis. But to answer your question, I mean, I don't think it's not like all encompassing, meaning Not all problems are amenable. Like I said, some of the things you cannot do with agentic AI. For example, if you have to be too precise, like a medical diagnostic situation, or maybe if there's too many regulations and that the system is incapable of adhering to, privacy, security concerns that you may not be able to overcome, things like that. You may not be able to deal with. You may not be able to adopt agentic AI solution there, right? This is more about this particular focus area, agentic AI particularly. What are the trends? And I believe the market for the overall AI is bigger, but this is growing rapidly. So the question is, at some point, the question to ask is everything going to become agentic AI at some point? Maybe, maybe not. But there are some that are more low-hanging fruits that will become agentic AI, where the data is repetitive. It's easier to break the tasks down, to partition among multi agents that are experts in that, to sort of put together an agentic solution that doesn't require human intervention all the time, so that they're more productive and it enhances your productivity, right? So think of it that way. But this is all about agentic AI. So beyond that, that's a much bigger pie, I think, in terms of the market.
Yeah. So Wendell is also asking, do you expect that enterprise agentic AI will be mainly implemented by a specialized IT function or by individual departments, business units, or even individuals?
Yeah, that's a great question. So actually, this idea of digital labor I talked about in the end. I believe that the organizations are going to have a department that would sort of look for solutions that are going to, so this last point I made, designing workflows that integrate these agents. There's got to be a department for that at some point. If these agents become very useful, then the question is, how can we design workflows that will enhance our digital labor force to augment what we have from the human workforce point of view to accomplish our goals much better, right? So I believe there should be an agency or a department, let's say, that would make those decisions as to how to design these workflows and how to deploy the appropriate agents for accomplishing these goals. So yeah, in the future, I believe there will be this need for this department to do all this in a way that is more, efficient. Let's put it that way.
Yeah. And Ananda Ganesh is asking, since the coding expertise might not be needed in the future, having business domain knowledge and AI architect level expertise is the key to sustain the job replacement. I mean, is that true?
So yeah, the coding today is much better than what I saw 2 years ago, right? Today it's so much better, right? And it's potentially going to get even better, right? But I think the important thing to understand here is, I think to his point, I think the fundamentals of the principles, the fundamentals of how these things are put together is something that would be marketable and valuable. So the strategic thinking part will come only if you fully understand how these things operate and how they function in order for them to be integrated together in the first place. So I believe those skills are still valuable and very useful. And I believe the more this lower level, let's say, engineers that are currently deployed to write code to then integrate up to a higher level function is probably going to be sort of a mix now. At least it seems like some of these companies are already doing that. And it could accelerate in that direction maybe. But for sure, the skills that will be required, for example, this new digital department that you would need in order for it to even design a workflow to satisfy a goal, would require knowledge at a deeper level in order to put something like this together. So I believe that skill set is still valuable. But the other ones, which are more repetitive, more where the agentic AIs are going to be very good at doing what they do, there's going to be that erosion in terms of jobs. And this is not me predicting. A lot of people are saying that very famous people are talking about it. So, and it seems like it's becoming reality too.
Okay, and Vrinda is asking, agentic AI in the design and operations process loops in power grids. Would love to hear your thoughts for power and electrical energy industry.
Oh, yeah. So think of it this way, right? Any function, anything you want to create, or any solution you want to create, right? I would just talk about, okay, what is so power and power grid solution? Let's say you're looking at, ability to keep it efficient, operate all the time, continuously, have a mix of, have very minimal downtime. I mean, sort of have objectives, right? And then uh, find ways to provide the agentic AI with data that allows it to reason about how to deal with those, how to measure what it's doing from from the objectives point of view, right? So that it can sort of navigate through its decision making, taking into account the constraints of the problem has in the first place. So how you want to think about it from that perspective, sort of, I'm talking really generic, like it could apply to anything, but generically you want to think about it as, how to formulate this agentic AI solution that takes into account the constraints of the problem in a way, and then finds the right mix of tools in order to be able to reason and make decisions on its own to satisfy a goal. So that is always the framework. Now, within that framework, for each of these areas you're talking about, you may have to maybe equip it with sensors, equip it with data, equip it with access to databases that log all the information that is required for it to make some decisions, right? To enable it. What exactly do you have to do? And then it all depends on the goal as well as to what you want to accomplish. But in general, I would say that's the formula or the algorithm.
Okay, there are a lot of requests for your slides.
Ah,
Yeah.
so yeah, I mean, I have no issues with that, Vishnu. I mean, I don't know how this is done, but is there a way to? Do you want me to send it to you and then you would distribute it, or they could send me an email and I'd be happy to send it to them?
So I usually upload if the speaker is okay, that is, it's up to the speaker because a lot of intellectual property has gone into it. So typically, if the speaker is agreeable, then I upload the slides to our website and then
Mhm.
link that those slides from everywhere. I mean, I send a mail and things like that, giving the
Okay. Okay. Yeah, let's talk offline, and I think we should be able to do that. Yeah.
yeah. And what else? There are a lot of questions, but I'm trying to be a little uh, choosy about them so that we cover the important aspects. Uh,
Yeah.
yeah.
By the way, I mean, everybody is welcome to reach out to me if they want to have a dialogue offline. Feel free to. Yes, Vishnu. I don't know if you can share my email or not, but I'm open to that.
Yeah, if you want me to, I can share your
Yeah,
email.
yeah. You can, for
Yeah.
people that you're not able to answer their questions, I mean, I can take it offline if you think that'll be helpful.
Yeah. So Srini Katreddy is asking, have you come across any experimental usage of agentic AI in the safety critical systems,
Mm.
like aerospace, railways, defense, etc.?
No, the answer is I have not, but I'm not an expert in that area, so I wouldn't count. I wouldn't say that's because I said it doesn't mean there is nothing like that there. To be honest and humble about all this, but yeah. So the safety critical systems is one area where uh, you've got to be careful using agentic AI because the repercussions of violating the safety requirement is huge. Um, you know, you may want to still have human in the loop to make the call. You know what I'm saying? It'll be very, at least today, at least as of today, unless you engineer the system to be so good and you've tested it thoroughly to look at all the corner cases, typically because the corner case is what will kill you in these safety critical systems. Like the Tesla cars today still fail sometimes. despite having all the training data they have had so far. So if it's safety critical, when you use those two words, then that becomes a question for, is agentic AI fully deployable in the notion of, in the sense of what agentic AI is all about, right? The ability to autonomously, sort of plan and act and anticipate when a safety critical output is expected every single time. That's a more gray area where I would say agentic AI, I don't think is there yet today. In general, this is in general for all the reasons I just mentioned, but you could probably deploy pieces of it which can then be used to inform the human that will ultimately make the call. So meaning that you can make it more efficient, make the human more efficient in his or her job, because the agentic AI is providing them with information that's reliable and on time in order for them to make a call that's useful, right? But to actually make the call is a very dicey situation in a safety critical problem.
So a related question I had was, uh, is there any quantitative or qualitative evaluation of the impact of hallucinations in agentic AI
Yeah,
deployments?
yeah. I think there are some papers that are talking about mitigating it, which means they need to know how to measure it in the first place, right? To mitigate something, you need to know what is it in the first place. I think there are some notions of um, hallucination and how to sort of then mitigate it. I mean, not just saying, but I I wouldn't be able to say something offhand here that would make that will be useful. But I think there is work going on in terms of measuring um, and using that as a gauge for improving it. Like this reflection idea would mitigate hallucination, for example, or retrieval or RAG-based systems would make the responses more sharp and accurate, for example. So there are methodologies that are out there to mitigate it, but then that's more open-ended without quantitatively measuring the degree of hallucination, right? I mean, um, but I think there is work going on. I forgot where, but maybe Princeton, but somewhere where they're looking at how to measure and then use that as a feedback loop to improve using techniques that I've just talked about today.
Yeah, and there's an interesting question from Chandru. He is asking, in terms of geographic adoption, is sovereign AI requirements factored into the regional adoption projections that you showed?
Is what AI? I missed that part. Could you repeat that? Sovereign AI?
Sovereign AI requirements
Uh-huh.
factored into these regional adoption projections? Because I believe you showed a slide, right, where
Yes,
you
I
had
did
some
put it. Yeah.
projections. Yes,
Yes.
he's asking if so. There's a lot of
No,
sovereignty kind of uh, aspects that are getting into the regulation, right? So, like
yeah, yeah, yeah.
Europe
So
has, yeah.
yeah. So this is the investments chart, but I think he's talking about the regulation chart, right? So let me go there. This one, I think he's talking, right? Maybe this is the one.
Yeah,
So
probably.
yeah, so if you look at the left chart, the focus areas that people are looking at for regulation in the first place is broken down by those metrics, those features. I mean, data security, privacy, the transparency of the operation. Is there a limit to the autonomous action? This is where the human in the loop is required for safety critical, for example. Human oversight requirements, how much human oversight should be there no matter what the agentic AI does. Are there standards by which we measure them, etc., right? So this graph here is basically related to the timelines for adoption based on these areas. So these are the things that people are looking at for regulation in the first place. And what this chart is saying is that these countries are more amenable for regulating it and are going to get there by 2030 in a framework where there's clearly defined rules for what, uh, when, and how you can use agentic AI for various um, use cases. And that if you meet or if you're compliant with the regulations, then you can deploy them basically. But then again, this is something that is projected here. Remember that. I'm not a, this is just a projection trend based on the data that I gleaned over. But yeah, so it's important to make that clarification that it's a projection and it's expected that, for example, if you look at this chart, US is lagging behind China and Europe. You would never think that way. But in this case, the regulation of the AI industry is less in the US comparatively speaking. Is it good or bad? That's a debate to be had. Clearly, if it's going to make an impact on society and people's lives, then maybe there is a need for some regulation in order to mitigate those effects.
The next set of questions is about threats. What are your thoughts on the vulnerability of agents, RAG solutions, and the major LLM suites to security threats like injection attacks? What would you recommend those working with these technologies do to keep abreast of the threat environment?
That's a very, very good question, and it's actually it's a real problem. To be, okay. So first of all, that's a real problem. Let's acknowledge that it's a problem, and you can have threats that would basically compromise either the accuracy, performance, and or maybe the ability to do the job in time, etc. If you were to mess with the agent itself by sending it fake data, corrupting the data, mixing the wrong agent with intercepting the communication between the agents in some way that messes up the overall performance of the multi-agent system, etc. Right? So I mean, this is a problem. This problem is mappable across many domains. I mean, this is side channel attack problem is there in the hardware domain where there are examples where people have used laser fault injection or things like that to mess with the functionality of the hardware or glean information about the hardware from the perspective of secure passwords or encryption data, etc., to decode information in the hardware. And so this side channel attack is a problem for sure. Even post-quantum crypto algorithms that are supposed to be robust to a quantum computer attack have recently shown to be susceptible to side channel attacks. So that's a problem. That's a real problem. And to my knowledge, I mean, I think people are starting to think about it. I don't know I can't cite for you any particular literature that I know of that would specifically address side channel threats for these models, but maybe it's a worthy thing to sort of research and find out. For sure, let's look at how they mitigate that, right? So for those problem areas or solutions, what they do, for example, in the case of laser fault injection, you want to obfuscate the bits that you're trying to read out. For example, as you know, in hardware, these are all zeros and ones, and if it can mess with the zeros and ones in terms of the voltage levels that the chip puts out, then your ability to decode what is there from a laser fault injection or a side channel attack would be minimized, right? Similarly, you could sort of draw analogies from that to what you're doing here by saying, okay, so maybe there is some way to obfuscate the communication between the agents in a way that minimizes the impact on any attacks that you may have, that you may do on the agent, for example. But the ideas are similar. I mean, there's still, it's not a foolproof 100% solution. It never is. This kind of security problems, it's a cat and mouse game. You come up with a solution, somebody else comes up with a better problem to solve. And so I think I predict that will be the case here as well.
Yeah. So there are a lot of questions, but I'll probably make this the last one in the interest of time.
Sure.
So this is about the ethical aspects. So what happens? Dave Hartman is asking, what happens if the agents decide that humans are nothing more than annoying pests? How do we stop unethical use by politicians, for example, gerrymandering?
Yeah. No, there is. Those are all real, problems. I mean, societal impact. Talk about societal impact. Those are clear dilemmas and problems that we need to look at. So, uh, this fake data and the fake, the whole fake, the things that people have put out there is a problem that everybody, you can see that today actively, right? It's not like it's a novel thing, a novel idea. And when you have agentic AI that relies on this data to make decisions, that can be a huge problem, because now you're talking about data that is out there, seemingly accurate or seemingly truthful, um, but not. And so the systems that are relying on it to make conclusions or make decisions in areas that such as media or entertainment, could be a problem. I mean, um, so how to so this question about how to so people are trying to address it in many ways, right? For example, the fake data, people are trying to figure out what are the signatures that can be used to detect fake in the first place, right? And if you can detect fake in some way, shape, or form, then maybe that can be informative to the agent to avoid or reduce weightage on in order to make its call. So the ability to sense and detect um, fake information based on some signatures that may be there, but it's not that cut and dry. People have even sold art uh, that look genuine, generated by AI, for example, in an auction that sold for millions of dollars, later to be found to be completely fake. So it can be as good as that these days. So yeah, it's a challenge, and that's an area. If you talk about areas of research, what the questions you're asking are clearly the leading edge of what needs to be done in order for the adoption to take place in a more reliable and useful way for the society. And we are not there yet, for sure.
Okay, with that, let us close the session. It was really a great, very insightful, and as you can see, there's a lot of interest. There are more than 200 registrations, as I mentioned, and a lot of questions. So, like you mentioned, I can share your email and they can contact you um, one-on-one
Sure,
for more questions. So I would
absolutely,
like
yeah.
to end with this presentation to you. Uh, so you're able to see the certificate, right? So if it,
Yeah, thank you so much. Thanks a lot.
yeah, if it was in person, we could have done something differently, but because it's online, so this is what it's a small token of our appreciation. So thanks again for sharing your insights and for your valuable time.
Thanks so much, Vishnu. I enjoyed it myself, and thanks to all the audience for asking all those good questions. Food for thought, and definitely happy to take more uh, on an email form if there's more questions. Thank you so much.
Yeah, thank you.
Thank you.
So thank you everyone, and the meeting is officially closed now. I will close the Zoom session as well, and do keep in touch.